Hello, my name is Tanner McBurnett. I am in Dr. Blair's 323 microbiology class. I am a secondary education major and my field of study is in general science. I'm going to be explaining the difference between gram-positive and gram-negative bacteria, and I also am going to go over the process of gram-staining bacteria. So let's get this thing started. I have a picture of a cross-section of gram-negative and gram-positive on display. As you can see, the gram-negative has two cytoplasmic membranes, an outer and an inner layer, outer and inner membrane. It also has a thin peptidoglycan layer with lipoproteins that anchor the outer membrane to it. It also has this is a hard word, lipopolysaccharide, it's a mouthful, and porons that are in the outer membrane. The outer membrane confers only modest structure strength on the gram-negative cell, but also is an effective barrier against most substances. The porons in the outer membrane function as a channel for entry and exit of solutes. So that's pretty much your gram-negative in a nutshell right there. Gram-positive bacteria does not have an outer membrane, but has a much thicker peptidoglycan layer, which is very important when I begin to discuss gram staining. As much as 90% of the cell wall of a gram-positive bacterium can consist of a peptidoglycan. Gram-positive bacteria form several walls of peptidoglycan and layer them on top of one another, as in gram-negative only form single layer. It is formed in cables about 50 nanometers wide, with each cable consisting of several glycan strands that cross-link as they form to become even stronger cell walls. Gram-positive bacteria also produces acidic molecules called teicholic acid embedded in their cell walls. Teicholic acid functions as a binding divalent metal ions like calcium and magnesium prior to their transport into the cell. In closing, one of the main differences between gram-positive and gram-negative is the fact that gram-positive bacterium have a very thick peptidoglycan layer, which is very important for them because they have stronger cell walls and thicker cell walls. As in gram-negative have the outer membrane but a very thin peptidoglycan layer, thus making them not as strong, not as thick as the gram-positives. Now I'm going to discuss the process of gram staining. The first thing you'd want to do when you get your stuff is first to start your flame. Get your slides, sterilize your slides by passing them through the flame 3 or 4 times. From that point, you would want to let your slide cool. Then you go on to retrieve your loop. Sterilize your loop by putting it through the flame until it's glowing red. Let it cool. From that point, you would want to take your bacteria. If it's in a broth, you'd want to get it, smear it onto your slide, let it air dry, then heat fix it by passing it through the flame for about 1 second, 2 or 3 times. If it is a solid medium, what you would do is you would wet your slide a little bit, take your loop, sterilize your loop, retrieve some of the sample from the plate, then smear it into the spot where you wet the slide at. Then again, you'd also let it air dry. Once it is air dried, you would heat fix it by passing it through the flame 2 or 3 times, allowing it to heat fix. You can look at this picture as a quick little illustration of what you need to do with if you have a liquid medium and or a solid medium. Once the bacterium has been heat fixated, what you would want to do is to get your crystal violet vial and then add 2 to 3 drops onto the surface of where you smeared the substance. There, you'd let it sit for about a minute, 45 seconds to a minute. Then you would stir or wash it off by using distilled water. Let that rinse off, rinse it good. From there, you would take the iodine valve, and then put some drops on your same spot. You'll let that sit for about 45 seconds to an hour, or to a minute, not an hour, 4 or 5 seconds to a minute. Then you would repeat the same process as cleaning it off with the distilled water. At this point, you would get alcohol and only add 2 to 3 drops of alcohol. When you do this, you need to wash it immediately. The reason why you do the alcohol, what I was saying earlier about the gram-positive having the thick peptidoglycan wall, the alcohol won't penetrate the gram-positive wall. It's too thick. But the gram-negative had the outer membrane and the thin peptidoglycan wall. The alcohol, when you drop it upon it, it burns that off. It destroys that, and it washes all the purple and the crystal violet and the iodine dye out of it. But once you do the alcohol, you rinse it off real quick. You take semphrinin, I can't say that word very well. You would take it, and then you would drop it in the same spot, let it sit for 45 seconds to a minute. Then you would wash it off. Once you're done with that, you would take it and blot it dry using blotting paper. You should have blotting paper in the lab somewhere. You wouldn't want to wipe it, because if you'd wipe it, you would wipe your stain completely off. You'd wipe all the bacteria off, so you need to use blotting paper. Once you get done with blotting your slide dry, you would put it underneath the microscope, starting at the lowest magnification, focusing in all the way until you get to the second highest magnification, which should be times 40. Once you're there, you would turn your microscope lens halfway at a drop of oil to where you're looking at, turn it to the 100 magnification to your oil lens. From there, you should be able to see what is in the pictures here. If you have gram-positive, it'd be a dark purple, dark bluish color. If you would have gram-negative, it would be pink. So that is the process of gram staining. I hope that you learned something. I hope you were able to understand what I was saying, and I hope this helped you in some sort of way. Thank you for your time.